Okay, let's continue with the remaining of this chapter. This is we have watched all the videos of the additive manufacturing systems in which they are using polymers, photopolymers, or hydrogels. And the first one was using photopolymer, again the second one, the third one, they were all using photopolymers, and they were curing these polymers with the help of some different light sources, some lasers, some special light equipment, some projectors, but the idea is the same. They have a photopolymer, and once you reflect some light on these photopolymers, they will be polymerized. And in the object analysis version, we have droplet deposition. We deposit drops on the table and try to cure them once they are being dropped. And in the B9 creator version, we have a projector underneath, and with the help of the light coming from the projector, we could polymerize this photopolymers. And the last one, it was a much faster version of the second one, and we said that they have a special window, it's oxygen permeable, and they adjust the level of oxygen by having some chemical reactions, electrochemical reactions, and with the help of this approach, they could increase the speed of manufacturing. And then I have shown you some discrete particle systems, some examples. They only use one channel for most of the time. If it's an SLS system, selective laser sintering system, they spread powders on the table, then with a laser, they try to sinter these powders together. And in the 3D printing process, it's different than the previous one. Again, we are using a powder bed, but this time we are not using a laser. Instead, what we are doing, we are jetting binder particles. So we can say that it's a multi-channel version of using discrete particles in that system. And then in the third row of FEMS actually classification, we have the molten material systems. In some of them, we have preheating chambers like nozzles. We increase the temperature of the nozzle so the material is liquefied, and then with a little pressure, the material is extruded. You may have a single channel or 2D channel. It's up to the construction of your system. We have a special system, but it's no longer available. There is not even a video about this one. They were jetting liquefied material on the decks, on the bed, but they weren't successful. And then in the FEMS table, in the FEMS classification table, we have the last row. In that last row, we said that the material input is some sheets of material, sometimes paper, sometimes metal. And we have seen an example, like actually an animation. They were using a roll of sheet material, but it can also be used for papers. In the upcoming chapter, in the chapter where we are going to discuss sheet lamination object manufacturing, I will show you more examples where they use papers. And the thing about this system is that since they have specific papers on top of each other, they need to join these papers also properly. And for that purpose, they use resin between the successive papers. So this is an important issue for laminated object manufacturing. And we have also seen the last example about sheet metal systems, solid sheet systems. They were using reinforced composite parts. Any questions, guys, up to this point, up to the end of this classification? These days, we also have some metal systems. In the earlier days, we didn't have much metal 3D printers, but right now, additive manufacturing community is much focused on metal systems. They are using some expensive, let's say, metals and try to fabricate complicated products. And in that actually research, we need to have some high accurate access control systems, more powerful laser technologies, and we may need to use multiple lasers at the same time to decrease the fabrication. We need to have special powders, so powder manufacturing is another issue. And further, we may also use metal sheets and the metal systems. Furthermore, we have, which is not in the table, but we have some hybrid systems. I have shown you the sort of conception. If you remember at some part of the video, I said that some specific part is subtractive. You start with an additive manufacturing pipeline, but at some point you use the fundamentals of subtractive machining or milling. And once you do that, then you can say that this is an hybrid system. Both we are doing subtractive operations and additive operations. And let's now quickly look at some milestones and the development of additive manufacturing systems. It actually started around the 1980s, in the first part of the 1980s. There were 3 different patents, somehow similar, but they were mainly based on layer by layer manufacturing. And these patents from Japan, France, and the US. And the one actually from Japan was much more realizable. And the guy who actually invented this system is Charles Hall. And then later he established this company, which is called as 3D Systems. This is the first prototype, not actually the first one, maybe the second or third one. It's an SLA system, stereolithography system, and they use liquid polymer. This is their initial drawings. In the earlier versions, they were using such a system. I mean that, let me use my pen. Where is it? Oops, it was closed. Let me open it first. Yes. If you look at these, in all of these, the table where you actually build your part, assume that this is the part which is to be built, is always going downwards. At each layer, it's doing some curing operation with the help of such lasers or light units, and then the table is moving downwards, which is a kind of a resin tank. We have liquid inside, as you see, but in this one, it's different. This time, the head is moving upwards after one layer is completed. And these days, the desktop versions of SLA systems or DLP systems are using this approach, which is much more better than the other one, since in the other one, your part will always be inside the liquid resin. This results in some problems, so they switch to this this approach. They are moving the table in positive Z direction. If you look at another type of additive manufacturing system, FDM. FDM is, by the way, the commercial name. This is let's write much neat form. Is deposition modeling. But these days, instead of FDM, we prefer to use FFF, which is the name actually given by the ASTM and ISO, which is fused filament fabrication. This is, as you know, the most popular additive manufacturing technology. So as I said, highly difficult to write with this one. Fused filament fabrication. So in summary, this is a trademark of Sukas's company. They use it always FDM, but these days we prefer to use FFF, fused filament fabrication. And it was patented in 1989 by Scott Crump, and he established again, similar to the previous guy. His company is called as Strata Systems, and now we can have these systems, these actually fused filament fabrication systems everywhere. Can anyone tell me the term of patents? For how many years the patents are valid?
30?
No, 20. Yes, we have some answers from the chat area. It's 20. So if you simply sum, yes, this is writing 89 plus 20, and that's why this maker movement starts around 2009. After the patent is expired, people start working on simpler versions of the FDM, and they come up with some cheap solutions, and that's why we now have such a term, democratization of manufacturing. If this patent didn't actually expire, we couldn't have such a democratization of manufacturing. With the help of it, now we have cheaper systems, cheaper 3D printers, and now everyone has access to 3D printing. So what are we expecting in near future? We will have more customized product, customized, let's say phones, phones, or I don't know, anything. For instance, we have an own phone company here. I will show you. Let me open the video first and then share the screen. Company called Own Phones, and they are producing earbuds for everyone. This is how they do it. So you simply scan your ear and then transfer this information to the company, and they produce an earbud for you. This is how they do it. You place a kind of whiteboard and do a kind of scanning with the help of your mobile phone. Now the thing is that this was a startup company and they couldn't survive. They failed. But obviously in the near future we will have more similar systems like that, more customized products. Since people love to use customized equipment, customized sportwear and other wear, we will have more of these in near future. Yes, and another final comments, we will be having more final products, not just prototypes, since the capabilities of additive manufacturing systems has improved a lot. We don't use them just for rapid prototyping purposes, but we use them for the fabrication of final products. And that's why we'll be using maybe direct digital manufacturing term instead of additive manufacturing in the upcoming years. Any questions, guys, about these issues?